Part A is asking you to find h prime of 6, and what we have here is h. Now, we've seen this question before when you're given a table and they want you to find the derivative of what's in the table. So hopefully you are thinking to do the mean value theorem. So we're going to do h prime of 6, and we're just going to pick 6 would normally be right in here, so I'm going to use 5 and 7. So that's going to equal h of 7 minus h of 5 over 7 minus 5. Okay, why don't you pause me, work it out, and let's see what we get. Okay, so your answer should be 5/2. Now let's read the second part of this, because not only does it ask you to find h prime of 6, but it says, using correct units, interpret the meaning of this. So what does 5/2 mean in context of the problem? Okay, well, hopefully you've read this, and they were talking about the height of a tree at time t. And it is measured in meters, and t is measured in years. So if h of t is measured in meters, and we have a derivative, wouldn't that be a rate? So then what I would just say is the height of the tree is growing at a rate of 5/2 meters per year at time 6. Don't forget to write at time 6, because that's what they're referring to in this part of the question. Now, part B is kind of very similar to part A, except that they're giving you what the mean value theorem is going to equal to. They're still, whoops, I thought my little pointer was on there. They're still talking about h prime of t, and we have a chart for h of t. So I would still think, oh, mean value theorem. But they're telling you that the mean value theorem has to be 2. So what you want to do is you want to go up here and pair 2 times together. So, like, for example, if you tried h of 3 minus h of 2, so that would be 2 minus 1.5, which is 0.5, and then over 3 minus 2, which is 1. So that would be 0.5 over 1, which doesn't equal 2. Okay, so let's try the next grouping. So let's say we did h of 5 minus h of 3 over 5 minus 3. Let's see if that equals 2. Okay, well, h of 5, let's look at that. That's 6 minus h of 3, which is 2, and 5 minus 3 is 2. And let's see if that equals 2. So we've got, in the numerator, we have 4 over 2, which is 2, and that does equal 2. And your explanation would be because h is differentiable on this given interval right here. Okay, and then it would be continuous as well. Now, when it's continuous, by the way, it would be continuous on this interval, but we would have equal signs under here. Okay, so less than or equal to, less than or equal to, because continuity, we can have the endpoints. And then the mean value theorem applies where there would be a time t for which h prime of t equals 2. This is just the definition of the mean value theorem. Okay, so we are going to be doing the trapezoidal sum with 4 subintervals. So we have 1, 2, 3, 4. Now the one thing, though, that we do need to note is that it's asking us for the average height. So that's technically average value theorem. Now, if you remember, average value theorem in this case would be the interval from 2 to 10 of, h of t, not h prime, that's h of t, over 10 minus 2. Okay, so essentially, if you want to think of this, this would be like 1/8. Okay, so let's look at this. This would be 1/8. So we're going to do this by doing our trapezoidal rule. And then we're just going to really multiply by 1/8 or divide by 8. Now, I will tell you, for you guys for this year, for 2020, average value theorem will not be on your AP exam, but any other year it would be. Okay? All right, so let's go through and let's find it. So we have, remember trapezoid, Remember the area of a trapezoid, right? So area equals 1/2 the height, base 1 plus base 2. All right, well, we're going to do this 4 times, right? So we're going to do 1/2. Well, the height of the first one is going to be from 2 to 3, so that's 1. So we've got 1. And then we're looking for our 2 bases. Here's one base, and there's the other. All right, so 1.5 plus 2. All right, let's go to the next one, 1/2. Well, the height for that one is the distance from 3 to 5. So that would be 2. So we've got 2 times, and then those bases are 2 plus 6. Okay, all right, let's go to the next one, plus 1/2. That height is 2, and the bases are 6 plus 11. And the last one, 1/2, and the height is 3, and then the bases are 11 plus 15. Okay, now remember this is non-calculator. Pause me, work it out. Okay, so this is the breakdown of what I got. Now remember, for 2020, you don't have a calculator, and actually, I think this was really a non-calculated question regardless. So I would leave it like this. And then the only thing I would do, and again for 2020, you don't need to worry about this, but for any other year you would, we were finding the average height, so we would multiply this by 1/8. And if I were you, I would just leave your answer just like that. Okay, so let's read through this one together. It says the height of the tree is modeled by G, which is given by this equation here. So the first thing that I want you to notice is that the height is G. Okay. And then if you keep reading, it says where X is the diameter of the base of the tree. So let's underline that. X is the diameter of the base. Okay, let's keep reading. So then it says, when the tree is 50 meters tall, isn't that the height? So didn't they right now just give you what G is? So they told you essentially that this is 50. So I know that this down here is 50, and couldn't I solve for X? Okay, and you know, these are things where sometimes if you just have nothing to do and you're not sure what you're supposed to do, at least do that. So watch what's going to happen, because if you put 50 here and you set that equal to 100x over 1 plus x, wouldn't this help me find x? I would cross multiply, so that would give me 50 plus 50x equals 100x. All right, pause me, see what you get. And you should get x equals 1. Now, we're going to use that, but let's just keep reading. Okay, so I'm back at that second sentence again, where it says, when the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of. Okay, so that is a rate, and that's the rate of the diameter increasing. So wouldn't that be dx dt? And that would be 0.03. Right, so we know x equals 1. We know dx dt is also 0.03. Okay. All right, so it says, according to this model, what is the rate of change of the height of the tree? Isn't this the height of the tree? So how do we find the rate of change of the height of the tree? Wouldn't we take the derivative? So all I'm going to do here is I'm going to take this equation right here, and I'm going to take the derivative. All right, so that's going to give me g prime of x equals, and I'm going to do quotient rule. So let's see what I get over here. So then when I do quotient rule, I'm going to do low, which would be 1 plus x, right? You know what? I don't think I'm going to fit that here. Hold on a sec. All right, so I just squeezed it in a little bit. So there's my low. Now d high, so the derivative of your numerator, and the derivative of that would just be 100, right? So that would be 100. But we just did that with respect to x, so don't forget to write dx dt. Okay, minus high, d low, which would just be a 1, right? You can put it or not. But again, you just took the derivative of an x, so don't forget to write dx dt. And then that would be over low squared. Now I'm hoping that you're starting to see why we did all of this to solve for x. Because now I can plug that in here, I can plug that in here, and I can plug that in here. I know what dx dt is, right? That's down here, 0.03. And now I can solve. All right, so why don't you solve for g prime of x and see what you get. All right, and I have 3/4. Don't forget, though, that you need a unit. And since it's the derivative, so that would be a rate, and that would be meters per year. So 3/4 meters per year.